Okay, you can start now.
Hello everyone, welcome to my presentation on modern manufacturing process. Myself Himel Roy. My presentation topic is electron beam machining. These are the outlines of my whole presentation. First, we will know what is electron beam machining. Electron beam machining, in short EBM, is a thermal material removal process where high velocity electrons are concentrated into a narrow beam that are directed towards the workpiece, which create heat and vaporize the material to perform high speed drilling, cutting or boring of a wide variety of metals. Principle. This is the mechanism of material removal in electron beam machining. The mechanism can be seen in the figure below at the right side. The electron gun produces such high energy focused beam which is made to invade the workpiece with a spot size of 10 to 200 meter. As the beam strikes the surface of the work material, the kinetic energy of the high velocity electrons is converted to heat energy. This will make the spot gradually getting bigger and deeper due to the melting and vaporization of material caused by the high power density. This process will be carried out until the desirable depth is created. The molten material will be casted out from the cutting zone by the high vapor pressure at the lower part. This is a schematic illustration of EBM. Here the workpiece is covered in a vacuum chamber. Here the vacuum is created by a high vacuum pump. Let's see what are the equipment used in EBM. Electron gun. This is the heart of EBM, which is made of tungsten or tantalum. It is simply a cathode tube which generates electron, accelerates them to sufficient velocity and focus them at a small spot size. The temperature generated at cathode is in 2500 degrees centigrade. There is a very low vacuum in the chamber. The second part is annular bias grid. It is an anode which is connected by the negative bias, so the electrons generated by the cathode do not diverge from its path and approach to the next element. At this chamber, the velocity of electron is almost half the velocity of light. The third equipment is magnetic lenses. After the anode, magnetic lenses are provided which shape the beam and does not allow to diverge electron or reduce the divergence of beam. These lenses allow to pass only convergent electron, thus a high focus beam is obtained. They also capture low energy electron, thus increase the quality of beam. Electromagnetic lens and deflection coil. Electromagnetic lens is used to focus the electron beam at a spot. They used to focus beam at a spot on workpiece. As a result, high intense beam reaches at work surface, which produce more heat and improve machining. The last part is workpiece and work holding device. It can machine both metallic and non-metallic material. The workpiece is held by suitable fixture which is mounted on a CNC table. The table can be moved in all three directions which control the shape of machining. Let's see how EBM works. This is the diagram right side. First, electron gun produces a high velocity electron particle. These electron particles move toward anode which is placed after cathode tube. Here at the cathode tube, the temperature is 2500 degrees centigrade. And now this high intense electron beam passes through magnetic lenses. There are a series of lenses which take care of only convergent electron passes through it. It absorbs divergent electron and low energy electron. It provides a high-quality electron beam. This electron beam now passes through electromagnetic lenses and deflecting coil. It focuses the electron beam at a spot. The high-intense electron beam impinges on the workpiece where kinetic energy of electrons convert into thermal energy. The material is removed from contact surface by melting and vaporization due to this high heat generated by conversion of kinetic energy into thermal energy. The whole process takes place in a vacuum chamber, otherwise the electron collide with air particle between path and loses its kinetic energy. These are the process parameters. Accelerating voltage, beam current, pulse duration, energy per pulse, spot size, and power density, which can be obtained from this formula. Advantages of electron beam machining. Very hard and heat-resistant material could be machined or welded easily. Highly reacting material can be machined easily because machining is done under vacuum. No physical or metallurgical damage results in the workpiece. Through EBM, we will not need any kind of further machining as the surface will not damage. Close dimensional tolerance could be achieved since there is no cutting tool wire. Hole as small as 0.002 mm diameter could be drilled. There are some disadvantages of EBM, which is high capital cost, high skilled labor required, the power consumption is too much high, low material removal rate, regular maintenance is required, and it is too much difficult to produce perfect vacuum, which is the most necessary part of EBM. Application of EBM in industrial and power generation field. It is used for drilling synthetic jewels in the watch industry. A smaller hole like 0.002 mm diameter can be produced in hard synthetic spheres. For making flash orifice in space nuclear reactors and turbine blades for supersonic aero engines, it is wire drawing dice flow orifices could be produced by this process. Fine copper wire can be welded to in transistors. These are the materials over which electron beam machining process can be performed. All material those can exist in vacuum. Metals like aluminum, barium, copper, nickel, molybdenum, titanium, then carbon, silicon, alloys, ceramics, composites, plastics, leathers. EBM process can be performed such a kind of shapes. Drilling of shapes of holes, drilling of non-circular holes, tapered holes, high-speed perforating of small diameter holes, engraving of metamix and vaporized layers, generation, through cutting, thin film machining, surface treatment including surface alloying. Summary. At the end, almost all materials can be handled using electron beam machining, which is this method is also very fit for micromachining with the jobs of
Okay, did you finish your presentation? Actually, I missed it, the last part, because there's a problem with the internet connection.
Oh, sir, I have done already.
Okay, thank you. It was a nice presentation. And can you go back to your slide before asking the audience on your slide, that's process parameters. Okay, that one, yeah. Do you know what is the accelerating voltage?
Sir, this is the accelerating voltage which is given to the electron gun.
Yes, yes, that's right. And this is not actually fixed. It depends on what kind of material you are machining, because some materials need really high amount of heat to melt, like for example, the refractory materials, or some
Yes.
kind of alloys which need really high amount of energy to cut using the electron beam machining. In that case, this accelerating voltage actually can be changed and altered, like it can vary from 10 kilovolt to 1000 kilovolt. And this voltage is basically the voltage difference between the cathode and the anode, okay, where the acceleration of the electron occurs. Electron is generated at the cathode, and then the anode pulls the electron from the cathode, and this is the acceleration of the electron occurs in that place, and that is why we call it the accelerating voltage. Okay.
Yes, sir.
Okay, any question from audience? Okay, I think there's no question. So